Hi, I'm Tim Zacharias with Cougar USA and your host of Building Value. My guest today is Kyle Hunter with KCI Technologies. Welcome to the show.
Hey, thanks for having me.
Yeah. We have a really great episode planned for you today. Going to be talking about Kyle's background, a little bit about HVAC systems, how the air and water are impacted, especially at partial load conditions. And most importantly, we're going to be talking about some bourbon. On Building Value, we go behind the scenes at some of the most iconic buildings in Texas to showcase the incredible people that design, build, and maintain them and their impact on the community. You could kind of set the stage for us a little bit. I know you've had, a broad past doing a lot of different things. So maybe talk us through a little bit what you did after high school and that path that you took to get to where we are now.
Okay, so
and then we can talk about the bourbon.
So, my dad is a pretty hilarious gentleman, and he was like, listen, I'll help you go to school if you go to school for engineering, but anything else, when summer comes around, you can go find a job and leave. And I was like, well.
Thanks, Dad.
I was like, I feel like college is a lot better than working because I always had some kind of a part-time job, farmhand kind of thing since I was 12. And I was just like, the movies make college seem pretty awesome. And while I didn't get any sports scholarships, I did get a partial scholarship, and I went to a school in Southern Oregon called OIT, Oregon Institute of Technology, and man, I love that place. It's really growing. A lot of smart people coming out of there. I was not one of those smart people. Every professor was like, Hunter, like, I'm glad you passed your classes, but I don't know if you're an engineer. And I'm like, well, okay, but it has amazing fly fishing, and I'm glad to see that place is doing really well. It's a beautiful place. So that's really engineering, like how I got into engineering really I like people having problems, and I like do whatever I can to solve those problems. So that's really how I got here. Water has always been a very big, interesting point for me. I cashed out my personal savings and retirement. I got about $35K and started a nonprofit called Stewardship International and ran around the world doing water treatment systems, and had an invention, which was a water transportation device. So sometimes, when the water's here and you want it there, you don't necessarily pump it. You put it in a ball and roll it. And that's what I did there. And because what I realized is the big need in developing country infrastructure was the fact that these Westerners were coming over with these mindsets and applying these strategies, these huge pump distributed water systems, and which is great when you have like law enforcement. But think if you have a community of 100 people and you have one well. Okay. And then, so if you have one well, all right, if somebody wanted to take over that water, if the meanest 3 people out of those 100 want to take over that water and make you pay them to use that water, there you go, you're done. So.
And you don't think about that.
Right. You don't until you're there, until you see it. And then when you see it, you go, no, that these pump systems don't work. And they do work once they grow into another level of security and another level of economy. But so what I wanted to do was, all right, how do I come up with a multifamily solution to water quality?
Okay.
That was like inside my head. How do I do that? So then I really was thinking about wastewater and these dry composting toilets, and then I was really thinking about, okay, how do you do chlorinization of water in order to take out everything that's in it, really mainly the fecal matter contagion, and then okay, so then it's just this cascading learning process, and then I was like, all right, well, fetching water is women's work, and so you're like, well, all right, so you have these young women that they're walking miles, they're exposed, things are, they're vulnerable out there. So how do we make it a system that we can't really remove the vulnerability, but maybe we remove the frequency of the vulnerability. And so then you start looking at, okay, you're going to carry a 3-gallon bucket on your head for anywhere between 6 to 12 miles.
Like 25 pounds.
Right. You and I both have young kids. They're about 25 pounds. Like, picture carrying that guy for 6 miles. Like,
There's no way.
that's not happening. Like, you will disown him probably 2 miles in, right? So then in that journey, I found a chiropractor that was, I wrapped him into my passion, much like, Adam and his pumps. And I was like, what would it do to a young, like, adolescent body to carry that weight every day for that distance? And so then he started putting together like how the spine was compacted and you get deformations and stuff. And I was like, man, this is a huge thing. We need a solution to this. And then the way we came to a solution, I knew all these problems. I had this great opportunity to go and spend some time with some amazing people in central Mexico and lifelong friends down there, and spent time in a barrio outside of Guadalajara, and I really love those people, and it really opened my eyes. And that's what started that. Was I told them, I go, listen, I don't have money, but I'm an engineer, and I'll come back with something. And eventually I did, but I didn't really develop this water ball and how to move the water in a different way until the Texas Board of Engineers decided that my engineering experience wasn't enough because I didn't go to ME accredited school. I was at Mechanical Engineering Technology School, which was accredited in that. And I was young I was 25 and didn't read the application well enough, and I was pretty disheartened from the whole thing, and drank way too much bourbon. And then the next day I woke up and had my feet on the floor, and I was just like, now what? And then I came up with the idea of rolling water instead of carrying it, and used the world's 2 most common materials, and which is industrial materials, which is HDPE and PVC. Use PVC for the handles, and just made it happen. And then to make that happen, what I did is I stepped out of consulting engineering for 2 years, and I was a high school teacher at Lanier High School in Austin, Texas. And then during the summers, I'd run around the world doing these little systems. So now, I'm back, and it would be great to be a teacher. It'd be great to be a baseball coach like I was. It'd be great to be running around the world doing these water treatment systems. But the older I get, the more I realize that's, I didn't really cause those issues particularly, and I need to find a way to look internally and how to sustain a family. So went back to consulting engineering. I've been doing that for about 15 years, and I get really excited about efficiency and sick building syndrome, and whenever I can find a client that's also interested in those things, man, I'll come up with any system you want as efficient as you can. We'll make lead look like code minimum, but you got to find the finances to do it.
Sure. I mean, there's some creative ways to do that as well, but I think it's that's a pretty unique perspective on things. And not a lot of people would have actually, you had the idea and the passion, but not a lot of people would have followed through with it.
Right.
And I think that's really cool, and that legacy still lives on, right? I mean, the water ball is still doing its thing. Right?
Yeah. I mean, we got to a place where we made about 40 of them. They traveled the world. I got one in my garage, kind of as a reminder that maybe, because I almost died several times in dealing with all of this. I was in the most dangerous city in the world at the time, called City Soleil, outside of Port-au-Prince, Haiti, and that was 2 weeks after that earthquake. So just a lot of decisions that a single 20-year-old man can make, but not something that like a grown adult should be doing. Like, so yeah, it was a heck of a ride. Gave me a lot of perspective,
Sure.
a lot of gratitude for where I'm at. But just I couldn't have planned it, and I think that's why I'm drawn to people who genuinely have a passion. Like anything, like, and like kind of talking to my wife right now. I'm like, even pumps, even pumps, like just go all in.
Sure.
All in on pumps and let your enthusiasm feed my enthusiasm, and man, I'll take that enthusiasm to the next person.
That's awesome. And I'll bring up briefly just the walk for water that we're involved with. I think
Right.
we talked about that a little bit, but that's an effort that Grundfos does in conjunction with Water Mission,
Mhm.
and it's a cool fundraiser the way they do it, and they basically make you reenact that process
Cool.
of going to go walk for
For-
water,
Mhm.
right? I love the name because I'm like extremely literal when I come up with names for our products and things like that. I'm like,
I could tell.
yeah, it's like this is not that's not my strong point, but it's great. And we took Mikey, my 6-year-old son,
Uh-huh.
and he got a smaller bucket.
Wow.
But like you said, I mean, we made it about 500 feet with that bucket, and he kind of looks at me like,
Mhm.
Dad, can
Yeah.
you carry this? And just to be able to introduce that conversation about the gratitude, like you said, to be
Right.
appreciative of where you're at, what we take for granted a lot right here, the
Correct.
ability to turn on the tap and
Yep.
have clean water, and to be able to kind of have that conversation,
Right.
even at 6 years old, has been cool. So that
Yeah.
typically in the fall, but we'll see this year if we're able to do
Yeah.
it again. So
No, I love those efforts. The water quality is the number one killer in the world of children under the age of 5, and I think adults over the age of like 55. And I love that. And anything that expands your mindset, any discussion that can expand your mindset, any nugget that you can learn from any situation in any human being is great. One of my most favorite things was when I returned home once. I hadn't had a shower or running plumbing in 3 months, and I took that first hot shower, and I was just like, wow. It was kind of like it was like time warping, because it was like I was still in the mountains of Guatemala until I took that shower, and then I was back in Texas. It was crazy.
yeah, that's I just can't even imagine going that long
Right.
without some of those basic,
Right.
utilities, I guess.
Right. And it's a different world, and walking for water is great, and finding a way to engage that in on any level and as frequently as possible. Those kind of like empathetic like practices
Mm-hmm.
to where you try to walk for water and walk in somebody else's shoes.
Exactly.
Man, there's nothing bad about that.
Yeah, we definitely enjoyed that, and I'm hoping we get to do it this fall again. So,
Mhm.
but here, let's drink to that.
Okay, to
Right.
water.
Yeah. So, tell us about this bourbon.
Okay, so this bourbon is the best bourbon you can get in the lower price range. Really complex. It's not very sweet. I don't like sweet rye whiskeys. I used to be. I got introduced to Scotch by a priest that was a friend of mine, and a lot of great stories there. But then,
Let's say I'm gonna
Right,
I'm gonna
right.
need some explanation there.
right. Well, so like one instance, we were at a bar talking, and he ordered Macallan 12, and the bartender goes, he goes, "Ooh, ordering the good stuff for the father," and Father Jim just looked at him. He's like, "I don't need any of your lip. It's been a long day." And it's little nuggets like that. I am Catholic, and I've had a very blessed experience in being so, because I've had just all these positive interactions. And while I totally acknowledge that they aren't always positive. I do believe that, there's some good nuggets there. And he introduced me to Scotch, and then I started I was like, this is too expensive. I need something a little more in my price point. And then I was daydreaming about getting in shape, and I realized that bourbon is the best price point between alcohol content and calories.
Okay.
So then I was like, all right, well then it's almost like keto fad to be drinking bourbon. So I stepped into that about 5 years ago and really experiencing the different bourbons and stuff. And this is where I come as a lower bracket price point, real smooth, very complex, and not all that sweet. So that's why I brought it today.
I like it. So this is the Long Branch.
Mm-hmm.
Yeah, this is the first time I've had it. I like it a lot.
Good. I think I came across it when I was like watching Longmire and the TV show.
Mm-hmm.
And I was like, Long Branch, Longmire, it's got to be good. I don't know. I kind of I've always let life kind of steer me in the good and bad. So that's how I find these things.
It's awesome. I like it. It's first bourbon tasting on Building Value.
Yeah, right.
And it's going to have to keep going.
Right, especially if we can get sponsorship. I mean, we can do anything.
Long Branch, feel free to reach out.
Yeah, right. Yeah, Wild Turkey.
There you go. So how did you said travel the world, decided to grow up. Is that how you ended up at KCI today?
So for the most part it's just this ever-evolving maturity, right? I was at the Astros playoff game a couple of years ago when they won the World Series, and it was against Boston, and it was the last game, and we won, and it was awesome. And these two guys got in a fight, and these older gentlemen were laughing, and they were just like, oh, they just don't have enough gray in their beard. And and for some weird reason at that moment, I finally started realizing what maturity even is. Like, what does that word mean to me? And KCI is... being a consultant engineer is tough. The markets are up and down. I think it's we kind of get misrepresented as having a lot of control, and we don't. We're as much a victim to the market and how it responds as anyone else. And our teaming strategies have to be pretty on point. We got to know a lot of people, and you rise and fall in favor every day. So. Learning better how to manage that and how to grow in that is kind of how I ended up at KCI, and just trying to always do a quality project. Like engineers often, and I'm talking mainly about myself because I don't like to talk about other people, but I always would kind of sacrifice the relationship for the product as an engineer. It's like you have this quality that you're trying to go through and that you're trying to attain, and just anything to get there. Like, just let's do that, anything to get there, because I thought that's all that mattered. And then you realize, man, the game's a lot more complex than that. Like, you could get there with the best product in the world, but if you don't have any of the relationships on the backside, you're never going to get that opportunity again, no matter how good the product is.
Sure.
Like, for example, people ask me, hey, why are you big on HTS and Texas Air Systems? And why aren't you big on Train in Houston? People ask me that because as a consultant engineer, people get a little worried. They're like, here, are you flat specking this guy and whatever? And you're like, no. I mean, the product to me, the quality of the product to me is second tier to the level of a relationship that you're going to bring to the owner. I don't want the owner to spend 2 weeks finding your service guy. Like 2 days finding your service guy, fine. But you see that in across, management and companies and different industries, the sales reps and the contractors and everything. It's like, while the product is important, that relationship and that continued investment is everything. And when you start learning the game on that level, then you realize okay, everything's so interconnected. And I think that's the big jump in maturity and understanding that is how interconnected everything is. And when you understand that everything's interconnected, life changes a lot for you.
Mm-hmm.
So and for me, a lot of that just changed because of kids and because of a, supportive wife. And I'm no longer this rogue agent that just does whatever he wants. So, which I was very good at, just being, not necessarily being smart enough to make anything happen, but willing to sacrifice anything to make it happen, which is a destructive personality trait when you let it go untethered. So I'm glad I, for the most part, grew out of that a little bit.
Yeah, a little bit of accountability and that sense of that you have, there's more that you're responsible for than just yourself. Definitely kind of forces that maturity to happen maybe a little bit faster than you're ready for.
Yeah.
So.
Well, like the fact that if you died, like there's no, I mean, that would have a lot of impacts right now for me because I have a family.
Mm-hmm.
And in my 20s, it would too, my parents and my sister and stuff like that. But as a 20-year-old man, I didn't think about it at all. Like it's like, let's do this thing.
Yeah. I used to fly 4 times a month, for work, and I threw on my headphones, watch my little iPod video, with episodes of The Office that I paid for, one episode at a time, and I thought I was, light years ahead, and it was no big deal. And now I get on a plane, and I got to take my little happy pills to kind of calm myself down, just to, because you get up in the air and you're like, man, what if this is it, right? And leaving everybody at home, like you said. So, yeah, definitely. Kind of but it also can drive you.
Oh, I think it's a huge driver when you learn that level of maturity, and I'm on the early edge of it. But I look at these gentlemen that have, in my profession as a consultant engineer, and you see them and they have a couple kids, they have a well-established family, and man, they are out there just hustling and grinding and going, and in our industry, especially as consultants and architects as well. Architects, this is true as well. I mean, there are a lot of workaholics in our world, but also there aren't at the same time, because there's a great level of kind of anxiety relief when you have work to do. The anxiety for people that are really type A drivers in the consulting world, that anxiety increases when there's no work. Like that's when you start seeing things like they're just so used to grinding away.
Sure.
And, I haven't had that conversation with contractors. I wonder how they do when they get furloughed and turned down, but
I'm sure it's similar. I mean, most of those guys are getting after it day in and day out. So I doubt they like sitting around.
Right. They're used to doing 12-hour days, and then you just sit there and go, there's nothing for you to do. I'm sure that there's a level of unease there.
Sure.
But yeah, no, everyone I know that has a healthy family, those people in our industry, man, they grind, they push, and that's why they're in leadership roles, is because they have something to lose.
Mm-hmm.
So
let's talk pumps and HVAC systems.
Right. I'm very interested in what you sent me, because what I saw from it was, I was like, wait, is everything that's old new again? Like, are we going secondary, primary? Like, is that what we're doing?
Kind of.
And then I was sitting there thinking about, so I've had a really, really good professional career to where I had kind of just the salty old engineer that was like in charge, and they were very difficult to work for, but mainly they were difficult because of, my immaturity. But, I mean, to be just, I learned a lot from them. And, as a design engineer, really about that 3-year, 5-year mark, you'll see the engineers that are truly interested in the industry start trying to figure out ways to optimize things. And so I started getting into VFDs and the pumping and stuff, and a lot of the control systems. And what I'm very interested in knowing about what you mentioned in email is a lot of the systems that I early in my career wanted to design, but nobody would pay for them. They would kind of be hunting.
Okay.
Because you would have sometimes you want to be efficient, and you don't have an understanding of what I call the system sensitivity. And what I mean by system sensitivity is like while your controls can measure to like the 10th of a second, the water molecule that's going through your system and, going the route of the system and then being used as a heat transfer medium and then coming back, maybe that's 15 minutes.
Mm-hmm.
Maybe it's an hour, but it's definitely not 0.1 seconds.
Sure.
Right. And so that's where I feel like a lot of the hunting would come in. And if you had a primary VFD, variable primary system, and from what I understood was some kind of variable secondary system, and I can only assume that that makes sense because these are fractional horsepowers that are now turned into ECM motors.
Mm-hmm.
So I get that. But I had a lot of questions about like I'm all in, but then I'm like, wait, how?
Yeah.
And then the other thing I was thinking, I was like, dude, how pissed off would I be if I had to walk around everywhere and change out a pump that's magically hung up somewhere and I don't have access to? And then I was like, and then I went down a rabbit hole and I was like, wait, do I put those pumps on the emergency light system? Like, because they are just ECM motors. So I got a lot of ideas.
Yeah.
I went down a couple of rabbit holes in my head and,
that's great.
Yeah, you presented and let's talk through it.
So, I mean, I would say if we're going to talk hydronic loops, chill water, heating hot water, the pumps are kind of the stepchild, right?
Yes.
It's like, okay, let's worry about the chillers, the boilers, and the cooling tower.
Mm-hmm.
Let's get that, and then our air handlers, fan coil units, all that. Those are the big things, right? And then at the end of the day, they're like, okay, by the way, we need to move water to all of these things, right? And it's like, I don't really care how the water gets there. I just need to make sure I have enough of it, right? And so, and I get that. You look at on bid day the cost difference between these things, and it's like, okay, the pumps, let's throw those in there too, right? But in reality, that water moving through the system is actually what's transferring all of the heat, right? I mean, we're taking the heat from the air, moving to the water to the chiller, and then out to the air through the cooling tower.
It's like saying the liver and heart are like really important, but blood doesn't mean anything.
Sure.
It's like.
I love that comparison. We do that all the time. If we're looking at the building, the water is obviously the blood, and then the heart is the pump, and then the brain is the controls.
Right.
And so really where this kind of goes along that same line is that you can put any pump in there and move it, right? And then, but you can only maybe control it to a certain point depending on how you size that. And where this conversation started with us was on the partial load conditions,
right?
Which, in general, if we talk about how pumps or other equipment may be selected, in general, is let's look at the worst case scenario, and make sure we're covered for that. But if we're just choosing a single pump, and our best efficiency point is at this condition that we may never see, we're always operating less than that.
And I feel like you and Sarah did a great job explaining that. And I love data. I was a high school math teacher. And, I guarantee, if any of my students ever see this video, they're like, God, he was the worst. But because I'm very passionate about math and statistics, mainly because I'm a big baseball fan.
Sure.
But so I loved what you all said. And, I've seen a lot of design engineers take and size something exactly what you're talking about. They'll put it in a duplex system, but they would. I learned this a long time ago, and I stopped doing it a long time ago. Really, I stopped it right when a 5 horsepower pump could be put in a vertical. As soon as that centrifugal pump, 5 horsepower, was in a vertical, now they have like 50 horsepower. They can be put in a vertical, like
hundreds of
horsepower.
Yeah,
hundreds. So now it's like not a thing because that's where the industry went. But as soon as I saw them take a 5 horsepower, I was like, now I'm done with the way things used to be, because what they would do is really as a design professional, all we're doing is we're calculating the maximum and minimum. Really, that's it. And that was fine in the 1970s. That is not fine now. We need to figure out something else. And when I realized that at about 5 years in, I was like, no, I'm going to do triplex systems.
Sure.
And then I stepped away from the 1780 and I stepped to triplex systems, the 3500. And the way I started doing triplex systems, which now after listening to you and Sarah, I might even go quadplex systems. And the reason why is when I did my triplex systems, and this is the same sequence I did on condenser water as well as the chilled water. But what I did is I said, okay, if I was at 80% of my design condition, okay, that needs to be satisfied by one pump.
Okay.
No, by two pumps. Okay. If I was 100% of my design condition, I'm going to get there by all three.
Okay.
And then what I said is I went to the chiller minimum, okay, in order to keep that going. And I wanted one pump to be at about 35% capacity at the chiller minimum.
Okay.
Okay. So it's kind of, there's not really redundancy there. And the old engineers, what they would do is they would go one, that does the chiller minimum barely, and it does, and you'll get to that peak and you're fine. And then you have a redundant one. And I didn't believe in that. What I figured was if you lost your pump and you're in Houston, Texas, I was like, all right, if you lose a pump and you need redundancy, my system would give you redundancy to about an 80% capacity instead of 100% capacity redundancy. But the controls and the selections I was giving you were really intended at a 50% duty point. But now I'm listening to Sarah and everything, I'm like, well, maybe I'm not as aggressive. I need to be more aggressive with that and focus more on like the 25 to 35%.
Yep.
And then I'm really doing something. So, and we could go off on a tangent about temperature reset on condenser water loops, because here in Houston, Texas, if you have a condenser water loop and it doesn't do temperature reset, just give me a call. I'll make you money, because that's...
Well, there's two ways to look at that.
Yeah.
Right? I mean, you could do the temperature reset, but you could also, at the partial load, drive the condenser water down if you're able to use multiple towers.
Right.
And increase the efficiency of the chiller. And that's, there's two different ways to look at it. And, okay, how much am I going to save by resetting on my tower versus improving my chiller efficiency? And where this all kind of ties back to that is with the designing the pump systems to that partial load, is being more efficient at the partial load with the pumps, which in turn will make the rest of the system potentially more efficient, depending on how those controls are Because ultimately we want to increase that delta T to the chiller.
So let's not forget about this distributed pump system.
Sure.
Because I'm going to dive deep on this.
Yeah.
I'm going to get into this over here.
Yeah, let's do it.
Okay. I agree with you 100%. Like, what if instead of a temperature reset, we just drive the temperature down and now that energy is saved in the chiller?
Yep.
What if? So where I come with that is I want to see a system, and I haven't seen this system yet, a water-to-wire full efficiency calculation to where I take my chilled water evaporator side and then I take my condenser water side and I put those on metered panels.
Okay.
So think of a controls dashboard, okay? Now I'm seeing the power from each pump system, power from the chiller, power from the cooling tower, and I have all of that. Then I wanted to do a comparative analysis and optimize that system across.
Sure.
Based off the electrical usage.
Yep.
Right then.
That makes sense.
That makes sense. But I haven't seen anything like that.
Well, I mean, like you said earlier, you got to find somebody to pay for it. But what's interesting is, I mean, if it depends on the type of cooling tower you're using too, right? Like you may not be able to meet the minimum flow or get enough coverage on the media for it to be efficient. So if you are able to spread that load of a single, say you have two chillers, two cooling towers.
Yep.
If you can take that single load of one chiller to two cooling towers, then you can then it may make sense to drive down.
It may.
But if you can't do that, it may be better just to reset your to your condenser water. But
without that data, without that data point and going water to wire and really figuring that out, I mean, you could follow the ASHRAE 36 optimized control sequences all you want. But what I'm saying is, and you could even grow this system that we're talking about. You could do a localized weather station. You could do an online linked weather station that gives you like a 10-day window. Like, let's say we're in the middle of a season, so things aren't really changing around. We could almost get to a place to where we're a predictive control system instead of a reactive control system. We could almost get there now. And with the chiller sequences, it's like, why wouldn't you make it so that, like, let's say you had two cooling towers. Why? And let's say we're in part load. We need to have stepped part load. Like, and you would want each tower fan on this metered system as well, because you would want to know the truth. Like if I was designing a building for you, I would do 2 to 3 cooling towers in this hypothetical situation. And I would say, okay, at max load, the fans are 100%, the water's going over the fill at 100%, boom. Partial load, I would go, okay, the fans are at optimum efficiency and the water's going over all of them. Okay. Now, a minimum partial load, I'd flow over all 3 with no fans.
If you get the free cooling, sure.
If you could get the free cooling, depending on that local weather station,
Mm-hmm.
you know what I mean? But in all of that's great ideas, and that's 15 years of experience and paying attention. But all of it's just an opinion. And what our industry really needs is, let's step away from opinions. Just because it's how you've always done it, that doesn't necessarily mean that's the right way. And while ASHRAE does a great job of R&D and data collection and doing white papers, I truly believe in the private industry and its ability to find solutions for itself.
Mm-hmm.
And this isn't going to work for like a Home Depot, like, you know what I mean? But it would work great for these institutional, for a university. It worked great. Anybody that has the longevity in their institution that's going to be around 25, 50 years, why not collect data for 3 years, have all the bits and pieces so the data collection's there,
Mm-hmm.
and then come back in a 3-year window and be like, all right, we know everything, and now let's optimize.
Sure.
That is, I know a lot of facility managers and that's what they want to do, but, they don't have the authority or the reporting structure to like make that happen.
Sure.
But I mean, all the facility managers I know, they own their building. They take a lot of pride in it.
Yeah, they want to know as much as possible, right? And
Right.
it's getting easier
Yes.
and less expensive to do some of those things. And I don't know how familiar you are with the TowerTech cooling towers,
I'm not.
but it's basically a modular tower that in itself. So it has up to 8, 10, 12 fans,
Okay.
smaller fans, max 7.5 horsepower each,
Okay.
and you ramp all of them up and down together with a single VFD.
Interesting.
And it's a spray nozzle water
Okay.
distribution system that's pressurized, and so it can handle anywhere from 100 to 300 GPM per nozzle. So basically, and there's one nozzle per fan.
Okay.
Right? So basically, if you're looking at it, like I can do between 100 and 300 GPM per fan. Like
Okay.
that's how much the flow, nominal flow
Interesting.
through the tower. But that's really where, when you have that type of tower, it's much easier to run at that partial load, especially
Yes.
across 2 towers.
So they took fan wall technology and they put it into cooling towers.
And the fans are on the bottom. They're not on the top.
So are they blowing out the bottom or are they blowing out the side?
Blowing up the top. It's a counterflow.
Counterflow.
And
Okay.
it has a
Well, that
water
makes-
collection system that allows the water to
Okay.
be caught and moved into a moving flow-through basin.
Okay.
There's not a standstill basin.
Okay.
And the air
I
goes
love.
up. So
Okay.
it's like I think the water's moving about 5 to 7 feet per second through the tower. So it doesn't
Okay.
actually sit there.
Right.
So
That's awesome.
So it does take, good piping
Yeah.
to it to balance it
Yes.
and to make sure you're not overflowed in one basin
Okay.
and not the other. You're starving another. But if you can use those multiple towers for a
Mhm.
single chiller on partial loads, that's where you can
Yeah.
either see, okay, am I saving the money on the energy of the fans?
Yep.
Or do I want to drive that temperature down?
Yep.
And save the money on the chiller. So it's kind of a
So if you had these multiple fans,
Mhm.
Back to this system sensitivity
Sure.
conversation, how many pumps would you have there? Because if a traditional HVAC system is operating at 25%, per what Sarah said, and I haven't looked at her data, I haven't had the time, but she's highly reputable, so
Sure.
I just believe her. She's smarter than I am, so I go from there.
Definitely smarter than I am.
But But if we have that, and let's say a normal system is this cooling tower and this chiller, and we used to be a duplex system, but now we have this crazy cooling tower and this distributed system that you're talking about. How does that impact the number of pumps and this pump selection?
Sure. I mean, you can still do conventional pumps with the TowerTech tower. So
Okay.
you would just need to run as many pumps as you want the flow. So it
Okay.
would still, let's say you have traditional condenser water pumps. You have one condenser water pump per chiller,
Okay.
but you would have motorized valves on the inlets of the towers to whether or not you're flowing through both or not, right?
Yes.
So your condenser water pump's still interlocked with your chillers,
Okay.
but you could, just like where we were going with the pump conversation, is designed to that lower flow condition and then add multiple pumps to get to that redundancy that you want at the full load. You'd have to have different controls to be able to either control that against, flow or the differential pressure. I mean, really you're looking for the flow to maintain the proper flow through there. And I think condenser water pumps, a lot of those may get overlooked for the balancing.
Yeah.
And it becomes critical with the tower type because you don't want to pull too much on the basin because there's just not as much margin for error. So if you're over pumping, you can draw that basin down, introduce air into the system.
Okay.
But if you're balancing those with flow, especially using VFDs, that's another place. You go out and you don't want to see a condenser water pump, crank down with a valve to balance it. But yeah, I mean, there's multiple ways to attack the pumping on the condensed water side that are still, relatively simple.
Yeah. My concern is just like things are easy
Mm-hmm.
when one thing is constant and one thing's varying, and things get crazy when both things are varying.
Sure.
And with that many fans, I've never even looked into that system, and with that many fans, maybe you can put me at ease when we talk about all these pumps out there instead of control valves.
Yeah, happy to dive deep into the tower tech whenever you would like to do that. So if we, but ultimately, the water doesn't know how many fans. But and if you lose a fan, you lose just a fraction of the capability, right? But you still have the free cooling there. So if we move back onto the chill water side for the distributed pumping, let's say you have a typical variable primary system. We're going to have our, probably large chill water pumps, size like you said, redundant for the chiller, on a VFD, looking at differential pressure, maybe proportional pressure for the whole loop, and then out at all of the devices, your air handlers, fan coil units, anything else, you're going to have a control valve and probably a flow balancing valve. So the control valve on the inlet, flow balancing on the outlet, and that is to as long as that unit is running, you're going to maintain that constant flow through the device, right?
Yeah.
So in order for that to work, the chill water pumps have to generate all the pressure for the system,
Right.
and then for the control valve to work, it has to have that differential. So it's going to be reducing that pressure. So, I mean, it's an energy using device, right?
Yeah.
So with the distributed pumping, basically you're taking anything that was a control valve and replacing it with a smart pump, an ECM pump.
Okay.
And you can do that and leave the existing control system in place.
Okay.
So literally that control system can just send that signal to the pump instead of the control valve. So it's just ramping a pump up and down rather than opening and closing the control zone. And then it has, like the Magnet 3 specifically has a flow limit feature in it. So if you say, I want to flow no more than 7 GPM or 2.5 GPM, whatever it is, through this fan coil unit, then it will limit it so you don't have to have the flow control valve as well.
So then does it do a minimum and maximum and then like a 4 to 20 linear regression to figure out, where you're at, or is it precise enough to sit there and you're calculating off leaving air temperature?
So yes to all of it, potentially. Depends on how you want to do it. So it does have a minimum speed, and it would be enabled and disabled by either the control system or that unit. If it's that unit's running and it needs water, it would enable the pump and then it would run. So you can either have that external control signal from building automation that's looking at the external or the air temperature, and it can send that 4 to 20 or 0 to 10 signal
Yeah.
and ramp it up and down, or it has built-in differential pressure and temperature transmitters in it, so you can look
Okay.
at the, or you can bring in an external sensor for temperature. So if you wanted to look at leaving air temperature or leaving water temperature, you could index against those,
Okay.
and it can control to that.
Okay.
So there's a lot of different ways that you can do that.
Okay.
You can also, like on a fan coil, you could also do it on differential pressure, proportional pressure, any of those control modes all built in to it. But the simplest way to do it is literally leave the control system as it is and just have it control the pump instead of a valve. And so what that does, it does a couple of things. One is now you're distributing out the load of the pumping to all of these smaller pumps. So your primary pumps can become much smaller. They're
Well, yeah,
actually
you would
not
take the coil drop out of the primary pump. You would take that
the
run,
return pipe,
the
everything.
return pipe. Okay. But with the primary, but with this primary system, for lack of a better word, with this primary piping system kind of behave more like a reservoir? Like, would it be smarter to make it flow slower and a little, like, not reduce the pipe size? And really what you're using the VFD for is just like a final tuning of the system. And then you have all these quick hits off these little pumps kind of behaving.
Sure. So you're going to have a bypass,
Well, of course,
in
yes.
the in the plan from the
Yeah.
supply to the return, and that's where the excess is going to
Yeah.
return. And so there's kind of two different parts of control, right? Like, so all the distributed pumps can do just what we said, and then you could take the existing primary pumps and just ramp them down,
Okay.
right? Or you can replace the existing primary controls with, like for this instance, the Grundfos controller. And what it does is it looks at first differential across the chiller to make sure we're satisfying minimum flow across the chiller. And then as long as that's satisfied, then it starts to look at 4 temperature sensors on the bypass. Okay, before and after the bypass on both the supply and the return.
Okay.
And basically
Interesting.
looking at those, it can know if the system is balanced or if the supply is bleeding to the return or if the return is bleeding to the supply.
Okay.
And depending on which of those is happening, it's going to ramp the pumps up and down.
Okay.
Right? So if the supply is bleeding into the return, then we can slow the pumps down
Okay.
to balance it back out. If the return's bleeding into the supply, then we need to ramp the pumps up, the primary pumps up.
Okay.
And so what they've seen in the trials on this is that just replacing the control valves with the smart pumps, they slowed down the primary pumps, but it was still the same primary pumps they had, was, I think it was 32% energy savings. And then they estimated over 50% when they would switch the primary pumps to this controls. But
and I totally believe it. And here's why I believe it is because on the air side we have a very similar system. It's we have a VAV series fan power box. These series fan power boxes are pretty much in concept the same thing, just an air instead of water.
Sure.
Because so anyway, but it is still about the same, especially if you control off the leaving air temperature of the air handling unit. You set that at constant. Are we at a place right now to where, let's say my entire water side system, I want to optimize it based off of my leaving air temperature, and let's say my set point of my leaving air temperature is 53. Okay. What if I wanted to optimize? What if we ran all the calculations, we did all the analysis, and the water to wire calculation said, you know what? Driving this leaving air temperature colder right now actually saves us money. Like, are we at a place right now with that full interconnected to where we could do that?
I think we're getting there.
Okay.
And so the last point I'll make on the savings, which was probably, I think, potentially the most significant, was the increase in delta T in the system.
Yeah.
So it increased almost 3 degrees. It was 2.7 degrees delta T increase. And I'm not a chiller expert, but you've got to think that that's going to improve your chiller performance to have that delta T, right? So that is where that impact starts to grow, right?
Okay.
Like same thing with what do you do with your condenser water versus the chiller, right? If we're trying to improve that chiller performance, then that was the ultimate effect in that trial. And this is not like a pie in the sky kind of a thing. I
Yeah.
mean, this is something that Grundfos is already doing and developed, and it's, on a roadmap for later this year in the U.S. But I mean, you could, without needing the controls for the primary, you could change out control valves to ECM pumps right off the bat.
Yeah.
And so that whole idea of this predictive, not even necessarily the predictive maintenance, but this analysis of the system based on all this information.
Yeah.
There's a company called Copper Tree Analytics that Grundfos has partnered with, and that's essentially what they're doing, right? They've analyzed all this information, have these algorithms to tell them, hey, this is how you can optimize certain things. And I mean, that's a little bit outside of what I'm able to really be able to talk about, but that, I think we're getting there.
Yeah, no, and it does seem to make sense based off the water side. I mean, on the air side, sorry. I mean, series fan power boxes have had ECM motors in them for probably, 7 years, something like that. So it makes sense to me from a movement of energy and efficiency. But what I'm concerned about is it usually takes 20 years for like somebody, because everybody's like that. I'm not going to be the guinea pig.
Sure.
And that's always the statement.
So I think just in general, there's some conservatism in design, like you're to take that jump to, and especially something like this, to say, okay, let's go ahead and do this.
Right.
Where I think in the aftermarket, you might be able to get to that building owner or property manager that would see the numbers and see the savings and be like, look, I'm willing to give this a shot on one of my buildings, and then I think that's where you can prove it out and start to grow it. So
I think what would be quite amazing, and I think the market entry point is that retrofit world, and I think the right way to do it is this. Let's say a client wants to increase their chiller plant capacity by 15%. And, their mechanical room's already built out and they get all this headache, and what if you're able to go in and be like, what if 15% was satisfied by just that 2.7 delta? You know what I mean?
Sure.
Like, think of the amount of savings, the amount of sales. Like, that's not even a sales pitch. That's just straight up easy money.
Sure.
And that's where, man, that would be a great opportunity to walk around and really talk about that. Another thing that I believe Adam brought up, that I was like really opened my eyes, was in these multiple pump systems. He said that they're talking to each other and they're figuring out what I should be doing, like as a package.
Yep.
Like, is it one running full tilt? Is it all of them running partial load? And they're just figuring out that themselves. And man, that's great. I wish we could. It's kind of like cell phone apps right now, to where like each piece of equipment's like, well, we can handle our stuff. I don't know about those guys, because the chiller guys will tell you the same thing. It's like our chiller, move all the energy, all the work to the chiller, make it do all the work for you. And then depending on the different, the chiller type, is like, no, oversize the chiller and make it run part load. And you're just like, and you get lost in all these different apps. I'm going to call them apps because that's where we are right now. And so like the cooling tower is like, I can make my stuff the most efficient. And the chiller guy goes, I make my stuff the most efficient. And the pumps, obviously, y'all can do that too. But what I'm wondering is, where are we going to get to this water-to-wire concept? And now we're tying all these apps actually together. Because, listen, the controls isn't actual programming. We need it to get to the place where it is actual open data that we are, really diving into and understanding. We need to get there. I mean, I think one of the biggest in the past, one of the biggest issues was really, like large companies having proprietary information and proprietary controls. And I'm of the opinion that if you had an actual control system that was actually programmed and actually looking at data, I mean, I could probably go to like 2009 IECC. You give me that equipment with a control system that's actually paying attention, and I will beat out a 2015 IECC design system. Like, let's know how the building's behaving.
Sure.
And then operate and optimize from there.
Yeah, it's going to be interesting to see how that all plays out because, I think when you look at a company like Grundfos where they build the pumps, they build
Right.
the VFDs, they build the controls, they're going to be able to control that piece of equipment
Right.
best, right? And the chiller guys are going to be the same with their chiller, right? However long experience they have controlling that piece of equipment.
Yeah.
But to have that bigger picture, like you said, to say, okay, what's actually happening in the system,
Right.
and how should I tell each piece of equipment where they need to be?
Right.
And I think that's that, whether it's Carpentry or anybody else out there doing those, that predictive analysis or whatever you want to call it, I think that's where you're going to be able to tie it all together. And,
correct.
Instead of having, you'll have that folder on your phone that has all those apps, but you just have to go to this one to optimize it.
It's like this industry has always been a lot of tribes. Like I'm the boiler tribe, you're the pump tribe, I'm the chiller tribe. We need to start like nation building. Like I don't know how to get everybody in line and start nation building. And whoever wants to put that together and actually get everybody in line and actually put that higher level of analytics over the top, man, I tell you, that'd be a good investment. Because what we also need to do with that is in these facility condition assessments, we need to take that to that higher level as well. You have the different disciplines going out and the different trades going out and looking at things, and all these facility managers really need a prioritization of what does need to be changed. But this concept of inventory management is something that people are really started really stepping into. But like as a manufacturer, I mean, Grundfos is ISO 9001, and that's a chain of custody supply chain management platform that says all these little boxes were checked. And it's like, why not take that to our industry, that concept, and really take it to the industry of managing equipment, having records and logs on, when they're maintained, how they're operating. And I mean, think of how, you could get to a place to where your filters automatically are purchased.
Mm-hmm.
Like you could write a web crawler that went and looked at your filters, did a price differential, and then was like, all right, and then order from that person. We could be there. It's there.
It happens, and like I said, it's still siloed, right? Like
Right.
so the IntelliHot, the water heaters, they have the telecare that monitors the system, and when those parts get to a certain percentage of service life, boom, here come the replacement parts.
Nice.
And that's just built in to their system, and it's because it's reading all of these systems all over the U.S. and aggregating the data and knowing when these things are going to get worn out.
Yep.
And there you go.
Well, and I know people are thinking about it. I mean, like 5 years ago, or I don't know. I forget, when you have kids, I swear to God, I used to have a really good memory, but I've started saying the other day because I just don't remember how much time has passed. But I mean, IBM, Watson, there was that commercial the other day, and the elevator repairman shows up at the front desk. He's like, I'm here to fix the elevator. And front desk guy is like, the elevator's fine. What's going on? And it's because Watson told him that something was, there was a high probability that this component was going to break soon and needed service. And, most of the facility managers that I talk to, they feel like they're understaffed and underfunded. And a great pivot from the mindset of I don't have what I need is the automation and utilizing data to get back to a place to where you feel like you're in control of your facility and it's back to yours and this is a great place to be.
Yeah. So like you said, comes down to getting somebody to pay for it.
Getting someone to pay for it.
Right now is going to be even more of a challenge.
Right.
But what's interesting is that there's been some programs that have been out for a while that facilitate exactly this type of capital upgrades.
Right.
So have you heard of PACE?
Yes.
Property Assessed Clean Energy. So
yep.
I mean that is an unbelievable tool that is out there to be taken advantage of for this exact anything that can reduce water or energy in a building.
Yep.
You can use it to pay for it over a long time.
Yeah, back when I had my own firm, we were one of the first firms that actually did a PACE project, and I think that's a great idea and a great initiative, and I wish that it had grown a little bigger and a little better. But the other thing that I think people aren't realizing on the COVID-19 thing is everybody's focusing airside, and properly so, because it's all about particle control and
Mm-hmm.
infectious disease. But what's gonna happen with that air side is the increased air rotations through the space and the increased outside air and ventilation. Okay, so now we're talking water side because we're talking about system capacity. Now, if you're not pulling data and you don't truly know how your system's running, you could run into a multi-million-dollar renovation project like that, because you're going to have an engineer, you're going to have a contractor come in and not have an understanding of the baseline of your system because you haven't been pulling the data. So you're either going to have to pay them to baseline your system, or they're going to go pull the nominal tonnages and the nominal capacities.
Sure.
And then, because they don't want to be liable for it, they're going to add a safety factor. And now maybe you're paying millions of dollars when what if only a 2.7 degree delta is all you needed to satisfy now stepping into a world to where our buildings actually take into consideration indoor air quality. I mean, that's a huge thing that I think people aren't realizing. The air side transfers to the water side. The water side is where it starts.
Yeah, absolutely. And that's not something that demand for that indoor air quality or those changes that ASHRAE is, those guidelines, those aren't going away. I mean, that's, I think, and people, the tenants, the guests, they're going to be driving that to say, what are you doing to make this building safe?
Well, I hope they do. But I had a great discussion the other day. I was like, so one of my favorite spots in Houston is Huey's. It's there in the Heights. It's like a Vietnamese gastropub. I love it. And anyways, the way I explain it to people is it's like Vietnamese food with a great bar. Okay.
Sounds awesome.
Right. Because traditionally that's not how those places work.
Yeah.
And so like you can go, and what I love about it is you go, you eat, you drink, you have a great time. Okay. You're about $40 in. It's not expensive.
Nice.
Right. Okay. But let's say that they do everything needed for COVID.
Mm-hmm.
Well, they're a DX. They got DX rooftop units and stuff like that. That $40 meal would be $200.
Yeah.
Are you going to go to a restaurant for $200?
Yeah. Well, and especially if they're limited on their capacity, right?
Right. Yeah. So then it exactly. And so the conversation is who's going to pay for it. And in the end of the day, I mean, the taxpayers always pay for it, but in some way or the other, you're as a private citizen, you're going to pay for it, either not through taxes and just inflated prices, or you're going to pay for it through subsidies and all these other things. I mean, what people don't understand, I saw this great presentation at ASHRAE. Let's see, I graduated in 2005, so this is probably 2005, 2006, and this is up in Portland, Oregon. And this guy must have been a genius of some kind, because he went and got an engineering degree, got bored, and then became a medical doctor. And I think his doctorate was like in lungs or something. I don't know. I was in my early 20s, didn't pay a lot of attention, but I did catch on to this, what he was talking about, which is the sick building syndrome.
Mm-hmm.
And that's a real thing. But that didn't drive any changes in the HVAC world. Like, I would say that outside of a hospital, there is not a building designed to reduce infectious disease outside of a hospital.
Sure.
Nobody's looking at it past that. So you're looking at what, 95% of all built buildings?
Yeah.
95% and 99% of the built environment?
Yeah.
So who's going to pay for that? And or are we going to pivot? And instead of this high density urbanization, are we going to go rural? Are we going to lean on our technology, this work from home? Are we going to start like micro satellite offices of only 10 people? Like, how are we going to behave and respond? Because the amount of money required that's going to come from us in one way or another, it might be insurmountable. I don't know.
Mm-hmm. It's an interesting thought, because like you said, I mean, I've already seen, comments on Nextdoor, Facebook to say, hey, what's this extra fee that I'm seeing on my restaurant bill?
Wow.
Right. And it's like, well, they have new costs for sanitization and upgrades and these things. And like, ultimately, are you willing to take the risk to go out,
Yeah.
and then are you going to pay more?
Right.
I think some people will, right? And hopefully we get to a point where we have the vaccine, but when's the next one
Right.
going to happen, or
Right.
do you have to continually be prepared for that next time that it could happen? So,
well, and I think I think anyone that understands the level of globalization that we're currently at, and that's only going to increase. And I'm all for globalization. Because of globalization, we've had a huge reduction in extreme poverty. And, and the more that opens up, the more countries open up, man, there's a lot of benefit there. But we're more connected than we've ever been. And, but we need to stay more connected than we've ever been. I think it would be I would think we'd miss out on a lot if we took everything to a virtual space. I hadn't, this is my first time being in front of a human being, aside from my wife and kids, and I miss this. There's an intangible.
Absolutely.
When humans we're so complex, and do you know much about horses?
No, I don't. Not
Okay.
a lot. I probably my brother-in-law has horses, so I probably should know more.
We should call a friend, right? So horses are very social animals. Okay, so if you and I'm not a horse expert. My mom and my sister are, and my dad, but I'm not. But horses are an extremely social animal, and that's why they build such close relationships with their owners and stuff. But let's say you have 4 horses that all know each other and they run around the pasture together and stuff. But then you take one of those horses and you put them in the stall. Well, they whinny, and the one in the stall will kick and cause all of this. And it's because they want that connection. They want to be part of the herd. It drives us. And I think that's what people are going to realize, is that when we had the connection, we all jumped in the virtual to escape it, but now we're all forced in the virtual. I'm hoping that drives that connection back.
Sure.
But back to the conversation, the globalism, I mean, sharing these ideas, learning from each other in person. I don't know about you, but engineers are notoriously horrible at communication. And I've done this as well. You're having a bad day, you send a horrible email, and in the email you are like Genghis Khan, like you will burn Rome down. But if you were in face-to-face with those human beings, you're not going to go to that level.
Sure.
You went to that level because you're staring at a box.
Sure.
You're staring at a computer. And that's why I think this globalism needs to increase. And if we look at it as restricting that as our solution to the pandemic, we're really missing out on things we just don't know. We don't know what it will inspire.
Sure.
Being around other human beings. So I love the idea of the ruralization and getting these ghost towns back and rejuvenated. Like up in Oregon, these lumber towns that, the lumber industry dried up, and, they're little ghost towns. And then, I mean, think of what it would do for Texas. Think of what it would do for the land-based oil right now, and getting, instead of 6 million people living in Houston and like roughly 4 million people in DFW, what if we had a whole bunch of these communities at like 100,000 people? And would we actually develop community again?
Yeah.
I don't know. But there's a huge possibility there. And I would personally, being in this industry, I would love for somebody to pay for all these buildings to get fixed. I mean, I would never run out of work. Never. Like, no one would be able to hire enough people to get it done.
Sure.
Like, everything would, and that would be great, but I think we'd be missing out on something.
Yeah. Like you mentioned the virtual when we first got into the pandemic, and I mean, we were doing the virtual happy hours, and we had a virtual trivia night, and but it definitely doesn't replace the real thing, the face-to-face. I think there are going to be things that will become Zoom calls that used to be, maybe boondoggles or something else. But yeah, I mean, there's going to be that level that, okay, this needs to be done in person.
Yeah, maybe
I think there's going to be a balance.
Yeah, and I hope so. I mean, maybe project managers, instead of hosting meetings because they're bored. They realize, hey, this is Houston, Texas, and I don't need to be stuck in traffic for 2 hours, so let's do a Zoom call. That would be great.
Mm-hmm.
But early in my career in project management, I as an engineer, I love process. And it's like, if you know the process, you know what's expected of you, therefore you're going to deliver. But where I really failed in that mentality is the fact that you just don't know what human beings are going to talk about. And until you get to 10 people in the room, you have no idea how that's going to shake out. And depending on the dynamic of the team, if you're really focused on the culture and the dynamic of the team, you're always going to have a positive result. Now, if you have people in that room that are a cancer to that room, you're always going to have a negative result.
Sure.
But the process and the control of the dialogue is never the right way to do it, because you never know. That the in-person thing, you just never know. You never know what you're going to get.
I mean, you could tell we're still kind of shifting people back into the office and, trying to take all these precautions. But you can tell there's definitely like a lift in morale for people that are back in the office and seeing people and, just having that interaction. I mean, I can tell you my wife's not necessarily excited that I'm not at home all the time. Hey, when are you going to be home? When are you going to be home? And because she's working from home and everything too. So it's
But it did feel good to actually put jeans on for once, and I was thinking to myself, and I texted a couple of my friends. I was like, when are we going to admit that business casual is like a t-shirt and shorts and flip flops? So like, are we there yet? Like, are we there as an industry yet? And actually wearing shoes and jeans was strangely nice.
Yep. Yeah, definitely had the Anchorman style going for a while. It was like a polo and then basketball shorts. Or something. It's like and your house shoes. As long as you looked from here up on the Zoom
ready,
you were
Zoom
good
ready
to go, right? So previous episodes of building value with using the technology definitely use that. So, but we are definitely wearing pants today.
Right. Hey, but if it gets us more views, we're not. So whatever. Whatever gets you paying attention, just let us know.
There you go. That's awesome. So anything else? I mean, we covered a broad spectrum today, but anything else, any other questions about the distributed pumping or anything else, any other topics you want to talk about? Maybe advice you might have for any of your clients or building owners, things like that?
I don't have any advice, but what I'm going to look into and kind of request is, what is the additional cost, the step from a triplex to a quadplex, and what kind of value do I get there? And seeing that, that's what I'm going to do personally.
Sure.
I thought I was like crazy doing a triplex, but I always love being a little crazy. So I guess 4 of them is what I'm doing now. So
hey, keep going, man. We can go 5, 6,
5. We're turning into the mock razor, right? Like we're gonna be Mach 20 here in a second.
Well, great. Thanks again for being on, and everybody that was watching and listening today. I appreciate you watching this episode, and we will see you on the next episode of Building Value.